For this video, I'd like to talk about multiplying binomials by polynomials. And remember that a binomial, bi is the root word for two, and nomial is terms. So this just means two terms. So like this expression in parentheses, p squared minus 6, or maybe 4x plus 1, or 3x squared minus 9x, or so on. It just has to have two different terms separated by addition or subtraction. So we're going to multiply a binomial by a polynomial. Here you can see a second degree polynomial, specifically a quadratic. And the strategy for this is straightforward, but it can be a little bit messy. So you want to be careful with these problems. And it doesn't matter which one you write first, but I'm going to write the binomial first. And when multiplying these, it works similarly to the FOIL method. Because you might remember when we multiply two binomials, you can either learn the FOIL method by multiplying the first ones, then the outer ones, then the inner ones, and then the last ones, and adding them all together. Or you can do it by distribution. And frankly, I would recommend learning this by distribution because that method will continue to apply here. FOIL only works when you have two binomials multiplied together. If you add in a third term in one of them, FOIL is going to miss quite a few terms. So with distribution, this x multiplies to both of these. And then this 2 multiplies to both of these. So each term in this first one multiplies to every term in the last one. And so you get your x squared minus 3x plus 2x minus 6 when you actually add them all together. And of course, you can combine the middle ones. So it's going to work basically the same way, except now this p squared is going to distribute to 3 terms. And then this minus 6 would also distribute to 3 terms as well. And so one way to know that you're on the right track is we essentially have 2 terms here, and we're going to multiply it by 3 terms. Let me rewrite that. I'm losing my r's. And so in total, we'll get 6 terms. And you'll see that, but the p squared gives you 3, and the minus 6 gives you 3. But when you multiply 2 terms by 2 terms, notice you end up with 4. So that's not a coincidence. If this had another term, like for instance, if this had a plus 2p in the middle, then you would have 3 terms by 3 terms, and so in total you'd end up with 9 terms. So this is just a way to check that you're doing it the right way and you're not missing anything. So let's start by doing the distribution. The p squared first, so p squared times p squared. Let me do it down here. That's going to be p to the 4th, because you got 2 p's multiplied here, 2 more here, and so in total you have 4 p's multiplied together. Then we have p squared times p, well that's just 3 p's multiplied together. Then p squared times minus 6, well that's just minus 6p squared. And now we go to the minus 6. So let me change colors for this. So this minus 6 is now going to distribute to all 3 of the terms as well. And so we get minus 6p squared, minus 6 times p, so minus 6p, and minus 6 times minus 6, which would be positive 36. And now that we've multiplied this out, we can combine like terms, and we want to write it in standard form, so highest power of p first. And let's see, we only have one p to the 4th, so let me rewrite that. So we have p to the 4th. Then we've only got one p cubed term, so I'll rewrite that. Now we've got a couple p squared terms, so this one here and this one here. Minus 6p squared minus 6p squared would be minus 12p squared. Then we have the minus, actually I forgot one extra underline for those. Then we have the minus 6p and the plus 36. You can see the underline method starts breaking down when you have more than 4. It gets a little bit messy. So we get the minus 6p and the plus 36, which just carry along. So this 4th degree polynomial would be the product of multiplying both of these together.